Okay, so the city of Lake Elsinore, we've got big dreams. We got big aspirations. If you haven't known, we've like the adventure capital with our skydiving, with our lake, with our storm baseball. We try to do it all, and the lake is the center of everything that we do. At the direction of our city council last year, we put together a lake management group. And this working group was set up by our city manager, Jason Simpson, and it includes Jonathan Skinner, our director of community services, Ben Foster, our management analyst, Rick DeSantiago, our public works manager, and Francisco Diaz, our superintendent of public works. And we spent 8 months last year kind of going through everything that we could possibly throw at the lake. Everything was on the table. We looked at every snake oil, every different processes out there. We reached out to every company. We vetted everything. And a lot of the times what happened was nobody could scale to our size. So they would send us their proposals. We'd ask, hey, what have you looked at? What size have you treated? And a lot of them, it was the ponds or it was a lake the size of 300 acres. Nothing really could get us to 3,000 acres or larger. And so that was one of the reasons why we started looking at Nano Bubble treatment with Moliere. They had the ability to scale up to what we need here in Lake Elsinore. So through that 8 months in our working group, we put together a lake management plan, and we looked at the different things that we can start small and get going into the lake. So we started with looking at algicide treatments, which we knew were safe and were, give us a starting point, and then also lanthanum-based products that Terry talked about earlier. And like what Terry said was Elsinore is a little different than Canyon Lake, and our pH is much higher. So alum wouldn't work as great here, and so we're looking at a product called Phoslock. Currently, right now, we're working with the State Water Board to get approval. We're almost there with the State Water Board that we need to check a couple more boxes, but we're hoping to get the Phoslock in the lake in the next month. We actually started the algicide treatments last October, was our first treatment, and we're putting small amounts of algicide every month into the lake. Total pounds per year is about 96,000 pounds, but for this size lake, that's kind of a drop in the bottom. So we went back and forth on the actual location of where we'd put the nanobubbler. We had a lot to think about. Originally, we were going to put it on land, but the length of the pipe, discharge, and intake lines would just be too far. Lake Elsinore is very shallow around the edges. It goes out about 150 to 200 feet. It's still like 3 feet deep. So there was definitely some concerns, and that's one of the reasons why we decided to put it on a barge. But the part of the reason why we put it where it is we also wanted the public to see it. We wanted them to be able to see something that's tangible, and it worked. People on social media, email, coming to city council are like, what is that in the lake? They drive by it on Lake Shore, and they see it. They can see something tangible, that the city is actually doing something for this lake, and that was really important to us. We want to be able to bring people to the lake, to the shore, and see that the nanobubble is working, and we are doing stuff for this lake. So when you work in your office and you work on paper, things are a lot different than when they actually get shipped out to you. So when the barges arrived, we were like, oh my God, this is much bigger than any equipment that we have. So our public works team we sat down with them and we were like, how are we going to get this in the water? How are we going to anchor it? And the public works team all right, we can make the anchors. We do it for our buoys. We do it for our floating restrooms. But when we started looking at the engineer's report and we're needing 1,500 pounds or more for anchors, we definitely needed to reach out to a company that has the experience. So we actually brought in Washington-based Ballard Marine Construction, and they came in, did the engineer's report, brought in the cranes, and set up the barges, and then set up the nanobubble. So it was quite an undertaking. It was, if you were out at Launch Point, it was a bunch of ants running around. They started on a Monday when it was pouring rain. They lifted the Connex boxes onto the barge, and by that Saturday, they had finished. So 1 week, they had the barge put together, Connex boxes, all the piping, anchored at its final spot. It was pretty remarkable. And then in addition, we installed submar mats. So we have this giant umbilical cord, which provides power to the barge. It's probably about that big. It is a giant cord, and we want to make sure that boats were going to go over it So we actually put mats over the cord, and then we also have buoys basically indicating that it's a no anchor zone. First 60 days, pretty remarkable. Around the barge, we have 5 buoys. We've got one at the discharge, 250 feet away, one north, one south, and then 2 1,000 feet away. I have access in my office every morning. My staff knows the first thing I do is turn my computer on and check the buoys. And it's on my desktop all through the day, so I can see real-time data. We're seeing dissolved oxygen, the ORP measurements, pH, a bunch of other things that Chris is going to talk about. But it's pretty remarkable that we have access, real-time data, knowing exactly what the barge is doing. We're not guessing. We're not saying that, it looks cleaner today. We know exactly what the barge, what the Nano Bubble equipment is doing in real time. So this is pretty remarkable. So I actually went out and got a Setchi disc. I always pronounce it wrong. Myself, and I went out on a barge with our community services staff and did it ourselves. And then the next week from WSP, we got the results from WSP, and we were pretty close to what they were getting. So I'm still fine-tuning my methods. But as you can see, in January, we were at about 0.3 meters, February 0.8, and last month we jumped up to 4.5 feet of visibility. So just in the first 60 days, we're seeing just amazing water visibility. Just to kind of put that in perspective, WSP, part of their monitoring, they've been doing these tests for the last 4 years. We have never gone above 2 feet. So 4.5 meters is roughly close to 15 feet. So you can see in the last 60 days, the water visibility has just been amazing. And we're, every day we're seeing, more and more improvements. So I'm going to actually hand that over. The rest of this is for Chris.
My name's Chris Steffen. I'm the Global Surface Water Director for Moliere. Moliere is a Hawthorne, California-based company. We're about 7 years old, and we have just under 3,000 installations in 55 countries. That spans across a wide number of industries, surface water being one of them. It's made up about a third of our business since we started. So why did Lake Elsinore give us a call? Well, decades of algae proliferation, deteriorating lake conditions, and causing frequent lake closures. You had an existing whole lake aeration system that was not providing the water quality or mitigating the algae. Source water includes treated wastewater effluent that keeps the lake at the desired level, stops it from evaporating, but at the same time brings in some external loading as well. And then really an interest in finding a solution, something that could be a foundational piece of treatment for the lake. So here's just a slide, 2022. Hate to bring up bad memories for the mayor, but summer of 22, the lake was closed in 22, the lake was closed for 8 months due to the harmful algae blooms. Sorry for bringing that back up. But it's been all over the news. Everybody here, you're well aware of the frequent lake closures here and the water quality. It's a big lake, 3,300 acres. Not sure that max depth is accurate, but a lot of acre feet, a lot of surface acres, as well as then again that wastewater effluent coming in every day. And so the first thing we did, as Adam highlighted, was set some baseline. We put some buoys in the water. Actually, there's 30 probes on those buoys, or 30 water quality parameters that are being measured by those 5 buoys. We also did a sediment hardness map of the 200-acre area around the installation point. And so not only did we find out what the true depths were, but we looked at what that bottom composition looked like. How hard was it? How soft was it? Was it a big pile of muck, or was it a really nice bed of sand and rock? And so that baseline monitored, and then we looked at aquatic vegetation as well, because aquatic vegetation changes when you improve water quality. And so we wanted to understand what our baseline was there. So it was really important to not just put the system in and then talk about what the results were. No, it was to establish a baseline to measure against. And so we had about 2 months worth of data baseline. About a month of it was actually pretty erratic. We had some sensor issues, took us a while to get those dialed in. And then we had a really good prior month to the deployment of getting very good, stable data. Just as Adam says, it's the first thing I do every day is go through a number of these installations and look at all of the water quality. This is what the system looks like. Two 20-foot containers on a floating barge system. Adam went through why we installed it at that location, out in the water. A lot of logistical reasons, public reasons as well. And then suitability as far as for treatment. Put it out into some depth where we are really into an area that could be a hot spot within the lake, and that could be really contributing to the poor water quality of the overall lake. This is what the one part of the system looks like. So in one of the containers, we have the Nano Bubble system. A Nano Bubble generator system has 3 basic parts. Something needs to pump water. Pull water out, put it right back in. The second part is the gas system. That's what this picture is of. On that right-hand side there, an oxygen concentrator, taking the same ambient air that we breathe, separating out the nitrogen to make a more pure form of oxygen. Then there's some receiver tanks back there to be able to stabilize pressure changes and provide some surge of volume to be able to take that gas and put it into the third piece, the nanobubble generator. That's what's in this system. You can see the big blue pump. That's a 2,400 gallon a minute pump, so pumping a couple million gallons a day. You can see the 2 silver pieces there on the piping with the blue labels on them. Those are the nanobubble generators. So that's the part that Moliere invented. That's the part that we have patents on. And that's that scalable piece that Adam talked about to allow us to be able to treat lakes or ponds no matter the size. So 2 of those in line combined with that gas system. So as the water runs through our devices, there's diffusers on the inside. And if you do a quick Google search, you'll quickly read that our patents call the shear method of making nanobubbles. And so as the water runs past the diffusers that are inside these devices, it shears off the gas, the air, the oxygen that's getting released from the diffuser, shearing off a bubble the size of a virus, 2,500 in a grain of sand, about 1 billion of them in the tip of my pinky. And so because these bubbles are so small, they just have a fundamentally different way of acting when you put them in water. They're hydrophobic. They don't even want to be in water, and so they move differently. They lack buoyancy because they're so small. They have a negative charge, allowing them to push away from each other. And so really what that allows you to do is to treat at one installation point and treat a really big body of water because these bubbles help spread. Now, the 2 things, though, that the device does, it makes these bubbles, as I just said. The second part is it dissolves that gas. And this is the part that most people don't understand about our devices. The bubbles don't carry the gas. They're too small. That's not what's delivering the oxygen. The oxygen is getting dissolved as a process while you're making these bubbles. And so you're dissolving a gas at a really efficient rate, over 85% transfer efficiency, regardless of depth. And then you're making these bubbles. They work hand in hand to be able to help spread this treatment over a really large area and direct it to where it's really needed, to the bottom of the lake. Summary of the results. It says 55 days because that's when I put these slides together. So basically a 60-day summary of the results, and the trends have continued and actually gotten really even more interesting. So in the top left there, you can see the 4-year average of what the TMDL monitoring for Secchi disc readings was. In the first 30 days, we went from 8 inches to 31 inches. And then at that 55-day point, we were over 12 feet in all of the areas of the lake. And that's not near the area of treatment. That's on the opposite ends of the lake. Blue-green algae, we have phycocyanin sensors near the treatment. I don't believe WSP has phycocyanin sensors on theirs. They have monitoring sondes on other parts of the lake as well, but I don't believe they have phycocyanin on theirs. But the phycocyanin readings in the 200 acres where we have our probes, in under 60 days, the blue-green algae went to near undetectable. Over 50% reduction in the entire lake. ORP, the oxidation reduction potential of the water. As many of you know, that's the ability of the water to handle contaminant. Got it, ORP, where it was typically a negative value to slightly positive. Got that to trend in all of the locations to over 300 millivolts. Visual improvements, because really it comes down to 2 to 3 things. Jonathan, 3 things being the third fish. But the first 2, 1, it's what you can measure, like with those probes. And number 2, it's what can you see with your plain old eyeballs. It's after 30 days. Elm Grove Beach. "30 days on the opposite side of the lake, here at Launch Point Park. It's the bottom of the lake that you see there. Again, over on Elm Grove Beach. This was when I visited the last time there on March 26th to take a tour of the system. It was my first time seeing it. It's pretty fun moment. Pretty fun moment. That's the self-cleaning intake screen. It's about 6 foot depth, where if you do a lake tour, you can see there's a rotating bar on the inside of it, and you can see it just sitting there rotating away. That's 6 feet down, and you can see it visible with your own 2 eyes. Got to remember, though, when we started, that water clarity is about 8 inches. That's what the discharge looks like. And so while you do see some bubbles, you do see a little bit of off-gassing. Remember, it's not 100% transfer efficiency, 85% transfer efficiency. And also there's some other bubbles that are made as a part of the process of making nanobubbles. That's due to how piping runs and some pressure changes. And so when you do take a lake tour or a boat tour this afternoon, you will see some bubbling, but that's not the nanobubbles. There's billions of those, trillions of those getting dispersed into the water column at the same time. Measurable improvements. Top left, you see that ORP going up, trending up. It's come down slightly as the temperatures have begun to climb here. It's come down slightly, but still at a really elevated level, hovering right around 300 or slightly below. Another important thing, though, is that oxygen saturation. Look at how erratic that oxygen saturation was prior to and even right following the installation. It's that diurnal change. Obviously, the algae is photosynthesizing, creating a bunch of oxygen, and then at night respiring and sucking it all back up. But as you can see, once you mitigated the blue-green algae, and that blue-green algae went to near undetectable levels just after the 1st or 2nd of March, that's when you see that oxygen saturation band really narrow. We see this in almost all of our installations. I was just in South Africa looking at 2 really large dam installations that we have there, and it's the exact same thing. You see that diurnal change get reduced, and you get a more stable environment. That's really the key to what our systems do. They enable natural lake processes to take over by oxygenating and creating an aerobic environment at the right place. And then you mitigate all of those external influences that are creating that instability and contributing to that nutrient flux from the sediments. And so by oxygenating those sediments, it's not just about digesting muck, although through that process you'll immobilize and sequester a few nutrients as well and prevent some root causes of the poor water quality. But it's really about that stabilization of that environment that stops that nutrient flux from happening. That's not Moliere. Moliere didn't invent that, as you guys know. Multiple speakers have spoken about that here today. What Moliere does is has a technology that actually can sufficiently oxygenate that sediment layer. That's the difference. But you see how that band got really, really close together, and it's not as influenced by the algae. And yet we're not talking about hypersaturation where you have to worry about fish kills and over-oxygenating. It's about creating an aerobic condition, not supersaturated condition. And it's really specific at the right place. One of the other most interesting things that you can see here is actually if you look at that bottom left and the top right, the buoys or those probes of the BGA, once the blue-green algae was basically gone to non-detectable levels, the chlorophyll A rebounded, and we've continued to see that. That's that presence of Daphnia that's now been identified in the lake by WSP. And some of those other beneficial things that used to get outcompeted are now not getting outcompeted because you don't have that prevalence of blue-green algae outcompeting them every day. Temperatures have continued to climb. I believe temperatures in the lake have risen over 25 degrees since the installation point, and yet we've still held really good trends on seeing really good trends on both ORP and dissolved oxygen saturation, and blue-green algae is still nearly undetectable in the treatment zone. A few of the slides blown up. That gap, that period right after installation, we commonly see that as well. And typically we see dissolved oxygen actually crash almost after installation. And that's because you're waking up the microbial community. Our PhD limnologist, I reviewed all of this with her, and she calls it that legacy effect. You have a certain microbial community down there that's used to the conditions, and they're flourishing in the conditions that they're in. Well, it takes them a little bit of time to transition to the new condition. And so that legacy effect where you had that older community that then had to change, a lot of it probably being facultative, just could change, and then you got that decrease in the blue-green algae. That tightening of the band, and you see it in nearly all of the buoys. It's really the same. And so if you study it a lot, you can see that there's a lot of mixing happening. But the fact that we have nearly the same exact readings across all of the buoys in opposite directions is really, really interesting, and just shows how well it can evenly saturate a large area. Temperatures continuing to climb, making it even harder. And then that influence of rain, right when we installed, that's when you got all of the rain. But I forget whose slide was up here earlier mentioning that it listed the rainfall events and the high nutrients that are coming in. Typically when you get a rain event 3 to 5 days after, that's when you'll get an algae bloom. That's when your DO crashes. All of the DO crashes first, and then it'll rebound once you get that algae. And so oftentimes when you get that rain, it actually creates worse conditions. I'm from the Midwest, as you can likely hear from my accent. Grew up on a lake, grew up on a river, and every time it rained, I didn't have a limnology degree. I didn't work in the water business. I was just a kid who grew up in the lakes, and I knew every time it would rain that we would have challenging conditions. Yet despite all of that rain, you still see the improvement that we're seeing here. Lastly, just took a few of the emails from the TMDL reporting, and this is from WSP's reports back. Just on March 20th there, about 5 weeks after installation, over 12 feet of water clarity. And then on March 20th at that same time, that's where they identified those species of Daphnia that were present in the water body that they hadn't seen in their 10 years of TMDL monitoring. That's all I have.
Appreciate it.